You wouldn't put up with a dripping faucet in your house for very long, so why put up with the same thing happening with your home's energy? If you're like most people, you've got lots of little energy drips happening all over your house, which together can add up to a lot of energy and money being wasted. Take these for instance. Incandescent bulbs are the cause of a big energy drip that can easily be fixed by replacing them with these guys, which use up to 75% less electricity and last 7 to 10 times longer. Replace the 5 most used bulbs in your house with CFLs, and that adds up to a savings of $25 each year. And how about all these red lights? They show that these devices are still using electricity even though they're turned off. That's another energy drip that costs our nation over $4 billion a year in wasted electricity. Put those electronic devices on a power strip and cut the power when not in use. 75% of the energy used by your computer happens when there's no one in front of it. How's that for an energy drip? Properly setting your computer's power management could save you about $33 a year. Using a programmable thermostat is another great way to lower your energy costs. Just set it and forget it for a cozy home with lower monthly bills. If your house isn't properly air sealed, that's a huge energy drip, and it's probably the cause of those dreaded ice dams on your roof. Keep that air inside where it belongs by sealing leaks going into your attic and properly insulating. You'll increase your home's comfort and save a bundle. That ancient appliance? Talk about an energy drip. If it's old enough to vote, it's time to think about replacing it with an energy-efficient model that can actually save you money in the long run. Fixing these energy drips in your home could save you about $575 per year. Multiply that by the number of houses in your neighborhood, by the number of neighborhoods in your town, by the number of, well, you get the idea. Keep your money where it belongs. Fix your energy drips and turn the sound of into. Help your friends and family save money too by sharing this video with them. Send them an email, tweet about it, or post it on Facebook.
Starting today, I know I'll never need to compromise. I keep on reaching for the stars, and soon I realize I'm higher than the sun. There's nothing they can do or say to ever slow us down. We got the right of way, you know we own this town. Our war is won. This is our time. This is our world. We're gonna pass the test. We're gonna win it all. This is our world. We've got one chance to make the grade and get the girl. It's time to shine. This is our world. We're never giving up, we're never gonna let you down. We came to play, we're here to stay, so bring another round. Let's have some fun. This is our time, this is our world. We're gonna pass the test, we're gonna win it all. This is our world, we've got one chance to make the grade and get the girl. Can you see that we're never gonna get away? We're gonna take it to the limit, stop the game and put us in it. Gonna fight until we win it all. This is our time to do it our way. Don't ask us why. This is our time. This is our world. We're gonna pass the test.
Hi, I'm Lee Patrick Sullivan from Energy Now, and I'm here to explain to you how the 3 most popular light bulbs work. Let's start with the incandescent light bulb. The modern version of the bulb is credited with being invented by Thomas Edison more than 125 years ago. Let's get small and find out how these things work. That's better. Now, once electricity is applied to these 2 rods on the side here, it travels up and heats this little piece of metal called a filament. It glows red hot, and that creates light. The filament is made of a metal called tungsten. Tungsten can withstand a lot of heat, which is a good thing, because these things get hot, reaching temperatures of 5,000 degrees Fahrenheit. You could fry an egg on this thing. Up to 90% of that energy is wasted through that escaping heat. So why doesn't the filament burn out immediately? Bulbs are skinny on the bottom and fat and round on the top for a reason. The fatty, bulby part allows the heat to spread out over a large surface area. The gas, which is argon in most bulbs these days, does the rest of the heat distribution. Now, compact fluorescent lights, or CFLs, have actually been around in their current form since the 1940s. You probably grew up with these lights in office buildings and hallways in school. The newfangled twisty compact type were designed to fit the millions and millions of corkscrew light sockets around the world. CFLs are a gas discharge lamp, which simply means they use electricity to excite mercury vapor. This vapor produces an ultraviolet light. But when the metallic and rare earth phosphor salt coating smashes into mercury, it fluoresces and creates a light the human eye can see. This light is in a different spectrum than the one created by the incandescent light bulb, and the softness of that light is one of the complaints people have with CFLs. Also, one of the things critics point to is the use of mercury in CFLs. That's why you should never, ever throw out a CFL in the garbage. Please take it to a certified recycling center. And the heat? Well, you can touch a CFL while it's on. By removing the heat portion of creating light, it takes about 85% less energy to light CFLs, and they last up to 8 times longer. And then there are the LEDs, light-emitting diodes. You notice I said diodes, plural. That's because just one diode wouldn't produce enough light. So a bunch of them are crammed together to get the brightness we humans need. The technology here is basically a tiny little light bulb that fits into an electrical circuit. But these lights don't use a filament. The light is created by the moving around of electrons in a semiconductor material. Since there is no filament, there is no filament to burn out, making them last a very long time. You've seen LEDs before. They make digital clocks digital. They're used in remote controls to send infrared signals to your TV and string millions of them together, and you get an LED television. In order to create the amount of light necessary, LED technicians borrowed from Edison's 125-year-old technology. They've made a rounded top. This allows for better distribution of light, and like the Edison bulb, it also helped redistribute heat over a larger surface. The LED folks also installed these little fins at the bottom of the lamp, allowing for more heat to escape and take some of the strain off the semiconductors. The result? A bright light that rivals incandescent, uses 85% less energy, and lasts 15 years or longer. I know what you're thinking. More diodes, semiconductors, fins. That sounds expensive. Well, you're right. Most LEDs that you would use in your home run about $50 per bulb. Compare that to the 50 cents you would pay for an incandescent, and it's a no-brainer what the consumer normally would pick.
Dạ.